Hello, future engineers, subscribers, viewers, and students. Here is a video in statics. This video is about solutions to problems given as quiz problems in my different classes in statics from the university where I teach statics. I hope that through this video, all viewers, subscribers will be able to enhance their skills in statics. So here is problem 6 in statics. A force of magnitude 450 newtons is acting at point A, which is at negative 324 meters with direction angles of 75 degrees and 125 degrees with respect to x and y axis respectively. Determine the acute direction angle with respect to the z-axis and the moment of the force about point B, which is at 1 for negative 2. So the relationship among the direction angles is that the sum of the squares of the direction cosines is 1. So that is cosine square of 75 degrees plus cosine square of 125 degrees plus cosine square of theta z equals 1. So solving for cosine theta z, extracting the square root, cosine theta z is plus minus 0.77719. So solving for theta z, so we drop the negative value because it is obtuse if we use the negative value. So it is stated here that we should compute the acute direction angle. So inverse cosine of 0.77719, theta z equals 39.00 degrees. Now for the force in vector form, 450 times quantity cosine theta x plus cosine theta y plus cosine theta z. So f in vector form, 450 times cosine 75 I plus cosine 25j plus cosine 39 degrees k. So in vector form, this force is equal to 116.47 I minus 258.11 J plus 349.72 K. So let's show it in illustration here so that I can present two solutions. One is by the scalar approach, and let's check it with the vector approach. So this is point A, which is at negative 3, positive 2, 4, and B is positive 1, positive 4, negative 2. So that's it. These are the components of the force. Positive 116.47, negative 258.11, and positive 349.72. This is point B, and this is the positive direction for moment about x. Right thumb towards the positive x direction. The curling of your forefingers will be this. Right thumb towards the y-axis, the curling would be that. And right thumb towards the positive z direction through B, that's the positive sense of moment. So for moment about dx, 258.11 is positive, and the distance is 4 plus 2, so 6. And 349.72 is opposite in sense in that direction, not in that direction. So minus 349.72, and the moment arm is 2. 2 is 4 meters minus 2 meters. So again, moment about dx is 258.11 times 6, where 6 is 4 plus 2, then minus 349.72 times 2, where 2 is 4 minus 2. So m sub dx is equal to 849.2 Newton meter. Then we sum up moment about y, the moment of the force about y-axis. So 116.47 is same sense as this positive sense of moment about the y-axis, by-axis. 116.47, the moment arm is again 6, 4 plus 2. Then this is also positive, 349.72. Don't mind 258.11 because it is parallel to the y-axis. So 116.47 times 6 plus 349.72 times quantity 3 plus 1, so 4. So MBY equals 116.47 times 6 plus 349.72 times 4. And it is equal to 2098 Newton meter. Then finally, for moment about the z-axis, this is the positive sense, 116 point, don't mind 349.72 parallel, it is parallel to the z-axis. So 116.47 times 2, 4 minus 2, that's positive. Then positive also 258.11 times 4. That's the z-axis, and the distance is 3 plus 1, 4. That's also positive. So 116.47 times 2 plus 258.11 times 4. 116.47 times 2 plus 258.11 times 4. Solving for MBZ, it is equal to 1265 Newton meter. So in vector form, the moment of this force about B is 849.2 I plus 2098 J plus 1265 K quantity Newton meter. In vector form, to check these answers, we have RBA cross the force. So moment about B is RBA cross the force, where BA is from B to A is along Z 2 plus 4, so 6. Along X is negative 1, negative 3, negative 4. Along Y is, we just go down by 2. For this is 4 and that's 2. So along X negative 4, RDA is negative 4, negative 2, positive 6. Then components of the force, then I unit vectors, then copy the elements of the first two columns. Then let's evaluate just like basket method in computing the determinant of a 3 by 3 matrix. So for I, 349.72 times negative 2, which is this, negative 349.72 times 2, or negative 2 times 349.72, then minus negative 258.11 times 6, so minus of negative, so that's plus 258.11 times 6, so it checks. Then for MBY, J, 6 times 116.47, which is this, then minus 349.72 times negative 4, so that's plus 349.72 times 4. So it also checks 2098. Then finally, about or along about the z-axis, okay, 258.11 times 4, which is that, then minus negative, so that's plus 116.47 times negative, and minus 116.47 times negative 2, or plus 116.47 times 2 is the same. Therefore, the moment at B in vector form is equal to quantity 849.2 I plus 2098 J plus 1265 K quantity Newton meter. So that's it for this video.